right, good morning, guys. Today we're going to talk about how body systems work together in a functional human being. We're still talking about animal systems. We're still talking about how they work together. This is going to be kind of a wrap-up of everything, so make sure you get your essential question down and you set up for Cornell notes. However, today we're going to talk about kind of all the systems together because we are going to talk about homeostasis. So homeostasis is all about balance, but instead of, balancing on a tightrope like this insane person, we're talking about how your body systems balance together. So what does homeostasis mean? It comes from Greek, it means staying the same, but the definition that you should write down is that it means maintaining a constant internal environment, and this can be for cells or organisms. Sorry about my handwriting. Cells or organisms, okay? Constant internal environment. So what happens when there is an imbalance, when things are out of balance in that internal environment, when something goes wrong in your body or when something happens that your body has to respond to? Make sure you have that question written on the left of your Cornell notes before you move on. Well, the answer is your body employs some different mechanisms, and we call those mechanisms feedback loops. So feedback loops work to let your body maintain homeostasis. Okay, and they work in two different ways. There are positive feedback loops, okay, and positive feedback loops get you back to that original state by adding more of the same. So the two examples of positive feedback loops are contractions. So when a baby is being born, a woman has contractions, those muscle movements, and those muscle movements keep happening one after another until the baby's out and she's returned to a non-pregnant state. The other example is blood clotting. When you cut yourself, your body will send more and more blood to that area so that it clots. So it's adding more blood to get you back to a state of not bleeding. Okay? Those are the two examples of positive feedback loops that you need to know. Now, most of the feedback loops that we talk about are going to be negative. Okay? So we talk about the opposite thing being added to get you back to the original condition. So if you're at a normal body temperature and you get cold, your body shivers, it adds heat until you're back at that normal body temperature. When your blood sugar's too low, you're hungry, so you add food to get you back to that state. We're going to look at these in a little bit more detail and draw them out, but adding the opposite is the negative thing. And those are most of our feedback loops. Okay, so let's see if you were paying attention. Is this example a positive or a negative feedback loop? So if I have my oven thermostat, the temperature of my oven should be 180 degrees. If I turn the electricity off, if it goes up to 190, so I turn the electricity off and it cools and I get back to that original condition. Or if it gets cool, the electricity turns on and heats the oven to get back to that state, what kind of feedback loop is this? If you said a negative feedback loop, you are correct. I added the opposite. It was too hot, I added heat. It was too hot, I added coolness, I took away heat. It was too cold, I add heat. The opposite thing is happening. Okay, so this is a diagram of how your negative feedback loop works. Your body starts here at normal. If something happens, if there's an increase in some situation in your body will take action to decrease it and make it normal. If there's a decrease in something like a temperature, your body will take action to increase it to normal. I'm going to show you two more specific examples, but this is the general kind of diagram of how a negative feedback loop looks and works. Okay, so let's talk about temperature. Why do we need a constant temperature? Because enzymes work best at a typical temperature. If it's too hot, we get hyperthermia. Too cold, we get hypothermia. Both of those could result in death if untreated. So how does your body keep you at that normal temperature? Well, if you're too hot, you could take off a coat. Your skin will get red. Your body will send blood to your skin so that it's at the surface and it can get cooled down. You'll sweat. All of these things will happen to try and get you back to that normal body temperature. If you're too cold, you can like move around. You might get goosebumps. You'll start shivering. There are things your body will do to try and warm you up and get you back to that normal. Now, obviously, there are conditions that are like we couldn't survive. If you jumped into a volcano, no amount of sweating is going to get your body temperature back to normal. If you decided to like go skinny dipping in the Arctic, which you shouldn't do, no amount of shivering is going to keep you from freezing. Okay? So there's a limit, but this helps us survive a wider range of environments. Okay, the other big example of a negative feedback loop is in glucose for the cells. So glucose, sugar, that carbohydrate is the basic source of energy. We know that's one of the reactants for cellular respiration. You should write that down, reactant for cellular respiration. And so your body has to control the amount of sugar in the blood, which is done by the pancreas. So this is in your nutrient absorption, your digestive system. Well, so how does your body do that? If there's too much glucose, your pancreas will secrete a hormone called insulin. And insulin tells the liver, hey, store this glucose, this extra glucose, as glycogen, which will eventually turn into fat. If there's not enough glucose, your pancreas will secrete a hormone that tells the liver to convert the glycogen back into glucose, okay, so that you have energy in your bloodstream, energy available for all of your cells. Again, this is how the other side of that feedback loop. And if it goes wrong with the insulin, as you might know, we call that disease diabetes. So you can't regulate your insulin levels, that hormone, so you need insulin injections. Okay, so the feedback loop all together, you have a normal blood sugar level. If it gets high, your body makes insulin, transports insulin around the body. So circulatory, digestive system working together to return it to normal. If it gets low, we make another hormone that puts insulin back into our, puts glucose back into our blood. Okay? So your body is working to keep you at a normal blood sugar level. And again, diabetes is what happens when there's an issue in this system. Okay, mainly with making insulin to bring your blood sugar down. All right, so last question. These two things, are these positive or negative feedback loops? Temperature regulation, negative. Blood glucose regulation, negative. And these diagrams are just a different way of showing you what we've already seen. This is your original normal state. This is your original normal state. This is what happens if there's too much and how we get back to normal. This is what happens if there's too little and we get back to normal. So it's two separate loops, they just connected together, okay? Two separate loops, cold, hot, that they connected together to get back to normal, okay? All right, so in your debrief section, I want you to explain how blood sugar is controlled by the pancreas and how it's the cause of diabetes. These are words you should know and use. And you should explain how it's part of a feedback loop. When you're done with this, look up at the screen for the rest of your instructions for today. Awesome.